Hi everyone, my name is Matthew Doyle, and today I'll be talking to you about my improved automated watering system designed as a major project for course EECS 1011. So let's begin by understanding how all the hardware components of the system are connected together. So it begins with the personal computer, which is connected via USB cable to the Arduino Grove board. This board contains important components such as the button, LED, and buzzer. From there we can move to the MOSFET sensor, which is connected to the board through a 4-pin buckled cable. The MOSFET sensor is connected to the 9-volt battery pack through the battery pack wires. It is then connected to the pump using the pump wires. The Arduino Grove board is also connected using the 4-pin buckle cable to a water sensor, which is submerged in the water reservoir to detect when the water level is too low. The pump is also submerged in this water reservoir. Going back to the Arduino Grove board, it is also connected to a soil moisture sensor, which is connected to the plant and soil through being submerged in the soil up to the submersion point. The watering tube connects the overall system by connecting the pump to the plant and soil to provide water when necessary. We can now move on to the physical system.
So this is the plant and soil portion of the automated watering system, which from left to right includes a sage plant, a lemon basil plant, and a green basil plant. Moving over to the green basil plant, there is a soil moisture sensor and the outlet of the water pump hose. Continuing to the connection point at the Arduino that connects the soil moisture sensor, the MOSFET, and the water sensor. The MOSFET is connected to a 9-volt battery pack composed of 4 AA batteries and connected to the water pump. The water sensor is also connected to the Arduino Grove board and is set at a point upside down that allows the water to not leak out, as well for the pump to not run to a level at which it will run dry.
So now let's try to understand how the system works on a programmable level. This system has been programmed using MATLAB. So we begin by connecting to the Arduino Grove board and by setting dry and wet moisture voltage levels, as well by setting a button pressed and a low water level voltage constant. So when the button is not pressed, if the soil is sufficiently dry and the water level is not too low, the pump will be turned on and it will remain on while the soil moisture is too low and the button is not pressed and the water level is not too low. If any of these conditions fail and are no longer satisfied, the pump will turn off and return back to while the button is not pressed. So in the event when the soil moisture is not sufficiently dry or the water level is too low, it'll then ask, is the water level too low? If this is proven true, an LED will turn on as well as the buzzer. The system will request the user to refill the water and await the input of enter to continue. Then the LED will turn off and the buzzer will turn off once enter is pressed. So now for the final scenario, for the button is not pressed, the soil is not sufficiently dry, and the water level is not too low. In this case, it will continue looping back to the beginning. In the event where the button is pressed, the system will close and the program will end. So now I will demonstrate to you the system operating by simulating wet and dry soil using water. So as the moisture sensor is removed from the water, the system believes the soil is dry and turns the pump on. When it is wet, the system believes the soil is wet and turns the pump off. Eventually, the water level will rise too low and a warning and LED can be heard. You can click enter, but the system still realizes it is being lied to, so the buzzer and LED remain on. Once it is refilled, you can click enter and the system will continue to operate as previously intended. The button can turn off the system.